To demonstrate how we create models in R, I'm going to use a simulated dataset called Sim1 that you can find in the Model R package. It has 30 observations of two variables, x and y. Here I'm just showing you the first 7 rows. Now, in 2 dimensions, a linear model is just a straight line. You have probably encountered the formula for a straight line before, y equals mx plus c, where m is the slope of the line and c is the point where the line intercepts the y-axis. Different people use different letters for the slope and intercept, but we're going to stick with m and c. R comes with a useful function that calculates the slope and intercept for us. This function is called LM, which is short for linear model. You can see the full list of parameters that the LM function can accept in its help page, but we only really need to worry about the first 2, the formula of the model and the dataset. Note that this is a different ordering of arguments than we are used to. In the tidyverse functions that we have been using so far in the class, like select or filter or ggplot, the first argument was always the dataset. This allowed us to chain multiple functions together with the pipe operator because the pipe operator inserts the output of the left-hand expression as the first argument of the function on the right. But LM is a very old function from an earlier era of R, before the tidyverse was created, and so it doesn't follow the tidyverse convention. If we try to pipe a dataset into the LM function, we will get an error because the LM function expects a formula as the first argument, rather than a dataset. With that caveat in mind, here is how we can use LM on the Sim1 dataset. The first parameter is the formula, and for our simple linear model, we write y tilde x. Note that we are using the squiggly tilde symbol here, not a hyphen. This tells the function that we want to fit a model where y, the response variable, depends upon a single explanatory variable x. Our second and final argument is the Sim1 dataset, which contains those x and y variables. When you run the LM function, R calculates the line that best fits our data. We can get a nice summary of the model's parameters by piping the output to the tidy function. This shows us the estimate of the slope and intercept for our model. It also shows us some error metrics for each of those parameters, but we can ignore those for now. As well as the individual parameters of the model, such as the slope and the intercept, we also care about the overall performance of our model, i.e., how well does our model explain the variation in the data? We can use the glance function to generate a summary of different metrics about the model itself. Here I am only showing the first few metrics that the glance function calculates, and in fact, we will only pay attention to the R² value. The R² value is a measure of how much of the variance in our data is explained by our model. It's a number that can be between 1 and 0, and in general, the closer the R² value is to 1, the better. You can see the usefulness of R² in the 2 graphs on this slide. In the graph on the left, the data fall perfectly on the best fit line of our model, and so the R² value of the model for this data is 1. However, as the data gets further from the model, the R² value will decrease. Take a look at the graph on the right. Here I simulated completely random values of y, so there should be no correlation between x and y. You can see that visually. Our model's line doesn't fit the data very well, and the slope is almost 0. And this is also indicated by a very small R² value that's very close to 0.